Completing the square. So completing the square is another method of solving quadratic equations. So previously, the other videos talked about how to do it when you are factoring and how to do it when you're taking the square root. So completing the square is just another method of solving those quadratic equations. In other words, finding the zeros for those quadratics. Another way you could say it is finding the x-intercepts. So we're going to look at this problem here. So notice how on this one, we only have a and b on one side of our equation. So the a is 1, it's just the number before the x squared, and our b is negative 16 here. So we're going to apply, I'm going to go through each of the steps on how to solve when you're completing the square. So first of all, when you're completing the square, you want your a to be 1. In this case, it's already 1, which is what we want. And we want to find some c so that we can factor it into a perfect trinomial. So I'm going to leave some blanks here, which is going to be the values that we're going to find for c here. That way I don't forget later on and put adding those two values to both sides of the equations. Remember, equations have an equal sign, which means both sides are balanced. So whatever I do to one side of the equation, I have to do it to the other. So that's why I added two blanks here. So the way we find our c is by doing the following. We want to take half of our b. So in this case, our b is negative 16. So just taking half of b just means we're going to be dividing your value for b by 2. So I'm going to divide negative 16 by 2 here. And then I'm going to square it. By doing that, we're going to be able to factor the left side into a perfect trinomial. So half of negative 16 is negative 8. If I square negative 8, I get 64. So every time I'm going to be adding my value of c into the equation, it's always going to be positive. So that's why I said you're always going to add your c to both sides. So every time we try to find our c, we're going to repeat this strategy here, taking half of your c and then squaring, taking half of your b, I'm sorry, and then squaring it to both sides. So again, I'm going to include some blanks here, which is where we're going to be adding our value for c, which in this case is 64. So let's add 64 to both sides. So now the left side of our equation can be factored into a perfect trinomial, which is going to be x minus, since our b is negative, our half of our b, which is 8 in this case. So if I were to do like all these steps of factoring that expression there, x squared minus 16x plus 64, it would turn out to be x minus 8 to the second power. Then we simplify the right side, which is negative 15 plus 64. Gives us 49. So now I'm trying to solve for x, so I want to leave x alone. I need to get rid of that exponent there. And we learned that if we square root an exponent of 2, then we can cancel that exponent. So that's what I'm doing right here. I'm going to take the square root of both sides. So that exponent and the radical cancel each other out. Now we're left only with x minus 8. And then we take the square root of 49, which is 7. Since 7 times 7 is 49. If you didn't know what the square root of 49 is, you can just simply punch it into your calculator and get that value. So let's add 8 to both sides so we can leave our x alone. So x will be plus or minus 7 plus 8. Now, since we have the plus or minus 7, that means I have two answers. So let's set up the two equations for those two different answers. So let's do the positive 7 first. So I'm going to do positive 7 plus 8, and we get 15. And our other answer is going to be where I include my negative 7 plus the 8, and I get positive 1. So my two roots for this quadratic is going to be 15 and 1. In other words, my zeros are 15 and 1. The solution to this quadratic is 15 and 1. So now let's take a look at another problem where we have a b, we have an a that's not 1, and we're going to have a c all in the same side. Remember, we want to come up with our own c so that we can factor into a perfect trinomial. So that means I want to get rid of the c that I'm given in this problem. How do I do that? Just cancel it on one side by doing the opposite. So I'm going to add 8 to both sides. And then that gives us only 2x squared plus 20 on the left side of the equal sign, then 8 on the right side. again, we don't want to have an A. We want our A to be, well, we want our A to be 1. Not to have one, but we want our A to be 1. So how do I get rid of that 2 there? I'm just going to divide each of our terms here by 2. So then that's gone. It becomes 1. So now we have 1x squared. Our A is going to be 1, which is what we want. And then we want our C, but we want to see that it's going to make us have a perfect trinomial. So I'm going to I'm going to include the blanks on each side of our equation so I can go back and add that C value there. And I'm just going to repeat the strategy that I did in the first problem to find my C. So I'm going to take half of my B. My B in this problem is positive 10. So I'm going to do 10 divided by 2, and then I'm going to square that result. So half of 10 is 5. If I square that, I get 25. So the value that C value that I'm going to add to both sides of my equation is going to be 25. So let's go ahead and rewrite this here. So those blanks, which is where I'm going to put the value that I got for C. So I'm adding 25 to both sides. Left side is going to be able to be factored into a perfect trinomial, which is what I want. That way I can just take the square root of both sides and then solve for x. This one, my b was positive, so inside the parentheses is going to be plus 5. So your perfect trinomial is just always x plus half of your b, or x minus half of your b, depending on the sign of b. Taking the square root of both sides so that I can cancel the exponent. And you're going to notice, again, that when I take the radical, or the square root of both sides, now my exponent is gone, and I'm just going to have x plus 5. Square root of 29, if you can't think of a number that multiplies to get 29 by itself, that's because we don't have one, or we don't have a whole number that does that, because 29 is not a perfect square. So I'm just going to punch it in my calculator and run to the nearest hundreds. So if I run to the nearest hundreds, it turns out that the square root of 29 is 5.39. Leaving our x alone by subtracting 5 to both sides, I'm going to have plus or minus 5.39 minus 5. Again, you see that plus or minus there. That means we're going to have two different answers. So let's go ahead and set up our two equations. One for the positive 5.39 and another one for the negative 5.39. Just going to simplify each of those equations there. And for the one on the left, I'm going to get just 0.39. Just subtracted those two numbers. The one on the right, since they're both negatives, I'm going to add them, and I'm going to get negative 10.39. So the solution, the roots, the zeros, the x-intercepts for this quadratic here would be those two values there. So you saw two different examples. Every problem is going to be different. It just depends whether you're given an A, whether you're given a C, whether you need to move it to the other side. But just get in the habit of looking for those two things first. So look to see if we have a C on the same side as where your A and your B are. And if you do, then move it to the other side like we did on the second problem. And if you have an A, just divide each of your terms by whatever your A is, and that's going to give you a value of 1 for A.